So let's look at a couple more problems from these exponential expression word problems when our answer is in algebraic form. And just to remind ourselves from the previous video that if we have some general function, we'll call it f of t, that these formulas are all going to follow a similar pattern. Namely, we'll have a, which we can call our starting value, multiplied by b, which is our growth or decay factor, all raised to the t power. So like I mentioned, a, that is our starting value or starting amount, and b is our growth factor, or it could be the amount that is decaying every year. And t and these will usually represent time. So with this in mind, let's look at this particular problem. And what you can see is that Shota invests $2,000 in a certificate of deposit that earns 2% in interest each year. So this is an investment tool that is commonly used in banks. And we're going to earn 2% of interest each year. So we need a function that gives the total value v of t in dollars of the investment t years from now. So to start this problem, let's first define our variables, just so that we can feel comfortable about them. So we know that t is time, and that time is measured in years for this problem. And v of t, that's going to be the total value. So let me write it as total value, and that's essentially the amount of money we're going to earn over time, and that unit is going to be in dollars. So from here, we just need to figure out our starting amount, which is $2,000. So when time is equal to 0, if we plug t equals 0 into our function, we will have $2,000. And comparing it to our general formula, this is essentially our a value. Now, this certificate of deposit, this CD, is going to earn 2% in interest each year. So every year, it's first going to give 100% of whatever we currently have, and then add 2% on top of that. So our growth factor will be 100% plus 2%. So we have to get the original amount back, and then we're going to add on top of that. And just to convert these to decimals, 100%, remember percent just means divide by 100, so 100 divided by 100, that's just 1. And this is 2 divided by 100, or 2 hundredths, so 0.02. And adding these together, we get 1.02. And so this is our growth factor, b, from our general formula. And essentially what it means is that every year we're going to be multiplying by 1.02. So let's put all this together now and create a formula. So based on our general formula, we figured out a and b, and then t is just our variable, that's our time. So we have that v of t is equal to our starting value, 2,000, multiplied by that growth factor, 1.02, and it's all raised to the t power. Now, if you want to feel more confident about this, you can make a table as well, just to see how this works out. And ultimately, that table, which we used in the intro video for this, justified where that general formula came from. But let's do that ourselves very quickly for this one, and I encourage you for the next problem to do that on your own. So we have t and v of t. So we know if we plug in t equals 0 to our formula, or just thinking this through, that we would have $2,000, since that's our starting amount of money. Now, when t is equal to 1, we're going to increase this by 2%. Or essentially, we're going to take our $2,000 and multiply it by 1.02. And we could determine the exact value, but honestly, we're just looking for the pattern, not necessarily the dollar amount each year. And for year 2, we'll take the previous dollar amount and again increase it by 2%. Or essentially, we're going to multiply it by 1.02 a second time. So we can write that as 2,000 times 1.02 to the second power. Likewise, if t is equal to 3, we're just going to multiply our previous amount by that 1.02 again. So we get 2,000 times by 1.02 to the third. And you can see any year you want to put in, let's just call it t to be general. We would have 2,000 multiplied by 1.02 raised to that t power. And you can see that is the exact formula that we figured out by just looking at the general pattern. So this would be our final answer for this question. We have 2,000 multiplied by that growth rate of 1.02, that 2% increase each year, all raised to the t power.